All right. A7 homework. Highly anticipated. Okay, so graphing systems of inequalities. So let's look at plot the point and tell whether the ordered pair is a solution. So remember, for it to be a solution when we're looking at a graph, it has to be in the shaded area and or shaded area and a solid line. Right? So if I plot 0, 0 here for number 1, the origin, this should be obvious that it is in the shaded area. So the answer is yes. It is a solution. Number 2. 2, 1. 2, 1. Dead center. Yes. It is in the gray. This is a solution. Number 3. Negative 2, 1. Negative 2, 1. All right, this one's a little bit more interesting. This one, it looks like it's in the gray, but if you notice, it's on a dashed line, a dotted line, right? So when it falls on the dashed line, we do not include these values in our solution set. So this is not a solution, right? Because it's on the line. Okay, moving right along. Algebraically, oh, my light died. Hold on. Okay, we can do without. So, algebraically tell whether the ordered pair is a solution. So here, we're going to plug in the value and just see if we get true statements, right? We have 2 systems and we have 1 possible solution. Remember that these solutions, there's an X and a Y. So we're just going to plug them in. And you don't have to solve for X or Y, right? It doesn't matter. A true solution is going to be true no matter how you move the variables around, right? A true solution should always be a true solution. So if we plug in X and Y, so 0 plus 0, is this greater than 1? Is 0 greater than 1? No, it's crazy, right? So this is false. Once you get a false statement like this, there's no need to plug it into the other one because I know that it's not true for this one, and we know that it's not a solution. I guess we could have just put no. All right, 5. Again, X and Y. Let's go with, so the first one, we have 2 times negative 1 plus Y, which is 1. Is this going to be less than 0? That's the question. So negative 2, 2 times negative 1, plus 1, is this less than or equal to 0? So negative 2 plus 1 is negative 1. Is negative 1 less than or equal to 0? Yeah, it is. This is true. So this isn't enough to say that this is a solution. We have to test the other equation. So negative 1 minus 1, is this greater than negative 2? So negative 1 minus 1, negative 1 minus 1 is going to be negative 2. Is negative 2 greater than negative 2? No, it's not. Negative 2 is exactly negative 2. So this is false. So again, we have no. What does it say? Tell whether, oh yeah, it's not. Not a solution. We have 2 knots in a row. Kind of crazy. Okay, number 6. X and Y. So we plug them into the first one. Give myself some room. 3 times 1 minus 2 times 2. Is this less than 1? So 3 times 1 is 3. 2 times 2 is 4. So 3 minus 4 less than 1. 3 minus 4 is -1. Is -1 less than 1? Yeah, it is. Okay, so we look at the other one. So the other equation, that is. So plugging in 1 for x, 3 times 2. Is this greater than or equal to 5? So 1 plus 3 times 2 is 6. Is this greater than 5? 7, greater than or equal to 5? Yes, it is. So 1, -2 is a solution. Or 1, 2 is a solution. Sorry. Okay. All right. So here we're matching. All right, number 7. We have 3 equations and 3 answer choices, A, B, and C. And we have to see which one matches up to this first one. So if you look at 7, right, let's just go down the line. So here we have y is less than or equal to x. So y less than x is a diagonal line, and we know that we're going to shade below the diagonal line. So in all these equations, or in all these graphs rather, we have the diagonal line. Here we shaded above it, so it's not A. B, the diagonal line, we shade below it. Okay, so it could be this one. And C, the diagonal line, we shade below it. Okay, so it could be B or C. Let's keep going. For x less than 2, so x less than or equal to 2, this is a vertical line at 2. So vertical line at 2. Well, actually, we know it's not that one, so I don't even care about that one. The 2 I think it is B and C. So vertical line at 2, vertical line at 2. Okay, but it says x is less than 2. So we want everything left of 2, shaded left of 2. So here, and we notice in C, it's shaded to the right. So right now, I don't even need to test the other one. But if I wanted to, y greater than -2. So here's -2, and we shade above it. So notice it is definitely B. The answer choice here is B. Excuse me. All right, for number 8. So B is no longer an option. So we're looking at A and C. So for 8, again, y greater than x. Diagonal line shaded above. Right away I can see it's going to be A. Because if B is not an option and C is shaded below, we know that this is A. And process of elimination leaves 9 with C. And you can verify those if you want. Okay. 10. We're going to graph the inequalities. So we're going to graph these lines, shade on the appropriate side with the appropriate type of line, solid or dashed, and then shade and see where the solutions are. Okay, so I'm going to use red. X greater than 1. So this is a vertical line through 1. And we want all the x's greater than 1. So it's to the right. Okay. For the other equation, y greater than -1. So that's a horizontal line through -1. Hey, it's supposed to be dotted. Okay, so hold on, I can fix this. My bad. So dotted line, and then dotted line, right? Because it's strictly, well, that's ratchet. Okay. We're going to shade above. So I'll do better in the next one. So we're shading above. Okay, so notice that the solutions aren't on the dotted line, but they're in the overlapping area. So the overlapping area, this darker area right here, not including the dashed lines. So there it is. All right, let's do better on that one next. Number 11. As far as right I can go, left as I can go. Okay. Okay, 2x plus y less than or equal to 3. I'm going to start by moving and solving for y because the y-intercept and the slope are not obvious at this moment. So minus 2x from both sides. So I see that y less than or equal, so this is a solid line for sure, minus 2x plus 3. So this is going to be y-intercept at 3. Y-intercept at 3. And we go down 2 to the right 1. Down 2 to the right 1. Make it make sense the other direction. Then we connect the dots. Solid line. Okay. Blue line. And we shade, which way direction do we shade? We shade below. So below the yellow line, below the red line. All right. There it is. Now for the other one, the blue line. Y greater than 3. So dotted line, horizontal line through y equals 3. So dotted. And we shade above 3 because we want bigger than 3. And we see that the solutions are going to be on the solid line and in the overlapping areas. Okay, 12. Y greater than 3x minus 3. It's already by itself, the y is. So we see here that this is going to be y-intercept of negative 3. And up 3 over 1, the slope, 3 over 1, up 3 over 1. And the other way, the other direction. And we shade above this line. Okay. X is greater than negative 1. X greater than negative 1. Oh, I did it again, bro. Okay, so you got to be careful with this. Just out of habit, I always put a solid line. I don't know why I do that. No, I'm going to hear about this later. All right, there's my dash dotted line. X greater than negative 1. So this is dotted line as well. Vertical line through negative 1. So dotted, vertical through negative 1. And we want x larger than negative 1. All the numbers larger than negative 1. So this is going to be to the right. To the right. Okay, there it is. So the solution is in that little, looks like a triangle piece. It's not a triangle because it only has 2 sides because the line's going forever. But where it makes the little point, but not on the dash lines. That's key, not on the dash lines. Okay, can we get through one of these without making a mistake? We got 3. Here we have 4x plus 2y greater than or equal to negative 2. So I'm going to solve for y. So we're going to subtract 4x from both sides. This means 2y greater than or equal to negative 4x minus 2. Okay, divide everything by 2. Cancels on the left. We get y greater than or equal. Negative 4 divided by 2 is negative 2x minus 2 divided by 2, which is 1. So here the y, so solid line, y-intercept is negative 1. And slope is down 2 to the right 1. Down 2 to the right 1. Okay, the next one, and shade above. We shade above because it's greater than. All right, shading above. Okay, next, y equals, or y greater than or equals, solid line, x minus 3. So no movement necessary. It's already in the form I want. Negative 3 is the y-intercept. The slope is going to be up 1 over 1. Do I have to put all the dots on this one? All right, there we go. Shade above. Shade above. Okay, y less than 5. Dotted line for sure. Horizontal line through y equals 5. So horizontal line, and we want less than 5, so smaller than 5. So can we see the overlapping area? That's the question. The overlapping area is the solid line and then underneath the dash, not on the dash. So basically right here, not including the dash. There's the overlap. Right, let's go the last one. Can't move it more left. Okay, you got 3 lines here. Let's see, x plus y less than 2. So I'm gonna solve for y by subtracting x. I'm gonna do it like this. So y is less than 2 minus x. So can we see that the y-intercept is going to be, it's a dotted line, and through 2, the y-intercept is 2, and the slope is negative 1, right? Even though it's not in the form, it is in the form, right? Like the b is obvious, the slope, the number in front of the x is obvious, negative 1. So down 1, down one and to the right one. You really can't see it, but. And we want to shade below because it's less than. Below. I need to make it perfect, but you know, whatever. Okay, there it is, below. And it's a dotted line. Wow. I even said it too. I even said it. Okay, it's dotted. Next one. Negative x plus y less than 2. Less than 2. We're going to add x to both sides. So it cancels. So y is less than 2 plus x. Dotted line. Dotted line. Y-intercept is going to be 2. Positive 2. And the slope is up 1 to the right 1. So up 1 to the right 1. Doing it correctly. Make it make sense the other direction. Okay. And we want to shade below. Below. Okay, there it is. And then finally, the third line, y greater than or equal to negative 2. This is a solid line. And we're going to shade above negative 2. So y equals horizontal line, solid through negative 2. And we shade above. And we see that the overlapping part is a triangle in the center, 2 dotted lines, and a solid line. So the solution is going to be on the solid line and up to the dashed line, but not including the dashed line. So something like this. All right, there's the solutions. Is that it? That's all the homework? I bet. So there you have it, guys. Hopefully you can remember to put the dotted lines. Catch you guys in the next video. Peace.